SwayamPrabha. Digital India. Educated India.
So, in the previous lecture 28, we had seen that how sound behaves under different meteorological conditions, that is air, when sound passing through air, sound passing through the different temperature, sound moving under different wind speed conditions, and we also told that it is a combined effect which should be considered, and there I already told that we also need to look into the topography, the landscape of that particular area, and we will continue with lecture 29 discussing on the topography and sound propagation and the historical context. So, earlier in the lecture 1, that is the introductory lecture, we had given an overview of the open air theatres which were designed by the Greeks initially and then by the Romans, which were continued, and we found how they had designed those. And now we can see on with this understanding of how sound behaves in open air condition, we will see that yes, really during the BCs also the same principles were adopted, which were learnt while we unearthed them, we tried to research them out, but yes, some concepts of acoustics were also in their studies. So, in this lecture we will see the influence of topographical condition, particularly the slopes, particularly the undulations and how sound behaves, then the plantations and the vegetations, and then we will look back into the historical context. So, if we see the picture in front of you, you see a hillock or a hill which is there, and the sound is produced at one end of the hill, which is not at all reaching or very small amount is reaching to the house or the receiver at the other side or the other slope of the hillock. If we had a house here on this side, sufficient amount of sound would have reached the receivers or the inmates along in this house. But on the other slope, no one is receiving sound here. It is only the diffracted sound which is reaching this particular area. If you look back into history, into the amphitheatres, they sorted after locations which were along the hill slopes, which were opposite to the sources of sound. So, the noise which is created in this particular area does not travel into this area much, and this is considered as a quieter area. So, we as architects also need to seek our open air theatre locations in such areas where this kind of hillock or hill could be artificially created, or a barrier could be artificially placed or planned, so that the noise which is coming or this where we see the source which is a noise should not affect or does not affect the other side of the slope. So, this is how we can take advantage of the topography and start our design. Similarly, we see we may not always get a hillside, but even we can think of a plateau, which the second picture shows, where source is at point A and we see some diffracted sound maybe little more than the previous case is reaching this particular area, which could be further treated by landscape elements. So, this house again where the receiver is not receiving much amount of sound which is desired or which he or she must have received if the house would have been located somewhere here. So, this downhill is an appropriate location for areas, for seeking areas where we need to put some acoustical, some space which needs acoustical quality. Here is another case. You may have a source from the downhill and you see the source sound is moving upward and is not getting or not affecting this particular area. So, this particular area and beyond is also a good location if the sound sources are at this particular area. So, we can take advantage of being at a raised level, so that sound from roadside, sound from industries can be curtailed, and we can plan for an acoustical space at a level elevated. So, through these small examples, we try to impress you upon the fact that change of levels can really change the amount of sound, whether desired or not. Depending on that, you can choose your location, and we should keep in mind that we need not always adopt measures, but taking advantage of the topography, we can plan our entire set of buildings or set of requirements that has to be fitted into a given site. Now, coming to plantations and vegetation. Here is a small picture where you see when the sound is coming from the source or from this direction, which has high decibels or high sound pressure level, passes through multiple reflections between the leaves, the branches, and it comes out on the other end with a low decibel. So, that means plantations and vegetations do also absorb sound, and hence they can be taken into account for when we are doing some outdoor design where noise has to be cut down, or noise is nothing but unwanted sound. So, when unwanted sound has to be cut down, we can take help of trees and plantations. Now, coming to how much, how many, what type, you will see if you can plan for dense amount of plantations with different types of plants having different types of foliages, then the amount of absorption is better. So, this has been experimented. So, on this end some noise has been produced, on the other end the readings are taken, and then depending on the source location they keep on varying, but it has been proved that around 5 to 10 decibels or even more can be absorbed by dense foliage of 15 to 30 meters. So, these are researched way back in 1970s, 70s, 72, 75, and even in 1990 many researchers have worked and come out with different foliage types, different formulas, but we are not specifically giving any formula, but you may keep this as an understanding or a thumb rule, like 10 to 15 meters of foliage will allow you to absorb 5-6 decibels of sound. Now, coming to grass, there may be areas where plantations are not there, but if the sound falls onto the grass, that is the angle of incidence is such that it encounters the grass surface or soft ground covered surface, then high decibel sound, a good amount of sound gets absorbed. So, grass or soft ground absorbs lot of sound. So, coming to the conclusions for plants and vegetations, you see that dense belts of trees of 15 to 30 meters absorb sound of 5 to 10 decibels. So, up to 10 to 15 meters you can surely get a good absorption of 5 to 6 decibels. Rustling of leaves may help masking of noise. Further, dense belts, different types of leaves provide better sound absorption. So, if you have trees planned, that is landscaped with different types of trees having different foliages like deciduous trees, evergreen trees, even coniferous trees, if you can plan such kind of thing. So, you have to know landscape, how what kind of plantations grow in that particular area, and you have the area or the provision of putting plantations, then you can create a belt of trees to check noise or check unwanted sound. Rustling of the leaves help masking the noise. So, if the noise are of similar frequencies noise, then masking of the sound can be happening because of the rustling of the leaves and the branches. So, noise reduction tends to increase with the height of the tree, and that has been researched or that has been experimented and researched that up to 10 to 12 meters the height of the trees are effective in noise reduction. However, if you have higher canopies at higher levels, they really do not have good effects. And finally, the height of the source of the sound and the distance from the source is also very important. So, with this understanding, the topographical effects, the meteorological effects, if we revisit lecture 1, if we go back into the early Greeks and the Romans, how did they plan? We will see that they had planned everything in the open air. They took advantage of direct sound reaching to their audience. They did not have anything to reinforce sound, and there was no concept of reverberation neither at that time and neither it happens in open air cases. So, there is no reverberation per se if we do not have any enclosure kind of effect. So, if the sound gets enclosed, then only the reverberation, that is coming back and forth things happen. So, we have to look into how the early Greeks really, whether they knew all these and understood and they planned, or really they came up with such solutions through their experiments. So, they had seating plans which were segmented circle more than 180 degrees, mostly on hillsides facing the sea. Now, here you see they had an understanding, they must have had an understanding that mostly on hillsides, so that the noise from the other side of the hill does not reach, and facing the sea, that also shows the wind direction. So, they accounted the meteorological condition as well as the topographical condition way back in the BCs. They had steeply raked seats and obviously low background sound because they were on the other side of the hill, and these all increased the intelligibility, and here you can see the source sound is directly reaching the audience. So, this is the Epidurus which was unearthed. It had 34 rows initially, which you see here, and later the 21 rows were added, and it had a radii of 60 meters or 186 feet, and the sound reached at the furthest point, which has been explored further by researchers of Georgia Institute of Technology in 2007. And here you see the plan, and here you see what the researchers have come out with. So, the researchers by the Georgia Institute of Technology finds that limestone sheets filter out the low frequency sounds which were not desired, and they allowed or amplified the high frequency sound from the stage. Now, these limestone sheets are considered as corrugated surfaces which acted as filters to emphasize certain frequencies. So, these limestone sheets are not just vacant sheets just added to create the seating, the item of seating, but the people, the designers at that time did consider limestone seating and this particular corrugated or folded structure, so that they get the advantage of cutting down low frequency sound due to footfalls of the crowds, etc., and amplifying the high frequency sound which was desired. Prevailing direction of the wind was also considered, and that was flowing from the stage towards the audience. So, that also helped in getting better sound quality, and the steep slope brought the people helped the sound to move to the farthest point, which was around 60 meters away. If you see this picture, you see dense foliage at the back. These actually did not allow the sound to reflect back, rather those were absorbed within the foliages. So, this is a present view, but yes, during it is believed that that time also such kind of foliages were around, and the trees actually could absorb the unwanted or checked the delayed reflection that would have disturbed the sound quality in this amphitheater. The Romans also followed the seating arc limited to 180 degrees. They also used arc features instead of hill slope. So, they had a high guard wall which actually helped the sound outside to not to enter into the within the amphitheater area. So, which was adapted by the Greeks along the hill slope. The Romans created arched facade to cover or enclose the sound that could disturb the performance, the sound from the performers. So, they had high wall at the back to cut down the noise from outside. They also added the stage house and the raised seating area of the stage, and had huge awnings to shade the patrons, and these actually helped in early reflections of sound. So, if you see the Roman theatre of Turkey, if you see the Colosseum which is here, if you see the Aspendius Roman theatre of Turkey, you will see these features. So, this is the typical plan and this is the view of it. So, you can see the colonnades at the back which helped in cutting down the noise. You can see at the front in the stage area there was a high wall which also helped to cut down sound, and you see similarly the sitting area is similarly planned like the Greeks, and these all helped in getting better acoustical quality of these spaces, and these were not done today. So, the understanding which you have formed from the meteorological conditions and the topographical conditions were adapted way back in the BCs. So, we can conclude that minimization of external noise is required, because from here in the next lecture we will go to open air theatre design. So, we can conclude that we need minimization of external noise, and that could be selected sites by selecting sites along hill slopes or selecting sites at a elevated level, or shielding the site with barriers or walls which could check the external noise. Sufficient directly propagated sound has to be encouraged, so that because there is not much reflection or diffusion or diffraction, anything playing a role here in propagating the sound, and it is the direct sound which needs to be moved, and for that we can take into account the wind direction. So, orientation is very much important, which should account for the wind direction. Sound from the first reflections, as the Romans adapted some canopy over the stage, we can plan when we look into open air design, we can plan or keep in mind that first reflections can be taken help of by providing some sort of canopy over the stage, so that the performers can get back their own sound, and it can help in sending the sound more towards the audience. So, moreover, the steps along the hill slopes also helped in sound reflection, as the limestone steps of the Epidurus showed. Use of material like limestone can be used and in the corrugated fashion, so that they can also help in first reflections. Control of late reflections and elimination of echoes by doing proper plantation at the back, that can help in checking late reflections. You can also propose or build up a wall at the back, so that it can cut down, it can allow the sound to move towards the trees and vegetations, and it can check the external noise. Orientation for acoustical advantages, that is orientation towards the wind direction, orientation considering the noise, where from the noise is coming, all these are to be taken into account when we start or when we think of planning for an open air theatre. So, with these conclusions, I would request you all to revisit lecture 1 and find the planning considerations followed in the ancient amphitheatres, which are scientifically proved and which are now scientifically proved and also applicable in today's context. And I would also like to say that we have not made much change in open air theatre design if we think of or see what the Greeks and Romans have done. We have actually followed their path, and till date similar kind of designs or principles are followed, particularly for open air theatres.